Okay, today we're going to be talking a little bit about streams and how to control streams. We'll also be talking about file streams and how to write and read from a file. So first of all, let's talk about the difference. A stream is just the way, the direction the input is or output is going. So an input stream flows into your program, such as a CIN statement brings information from the keyboard. An output stream goes out of your program, such as a cout statement writing text to the output. Now, those CIN statement and the cout statement are part of the IOStream library, but all of that is inherited by this FStream library, which we're going to use to write and read from the file. And those are inherited from the same parent. So it's going to look very similar. Which is kind of nice in C++. So we have CIN and cout, which goes to the keyboard and the screen, but you also have CErr and CLOG. CErr is if you don't want it to go to your output screen, it's just in case there's an error, you could put a CErr message in. And CLOG is the same thing, but it stores the information someplace. Now there's a couple of things you can do to modify the output. So, and we've done some of these before. Let's just show you a couple throughout here. So here we've got cout.setf, and it says show positive and show point. So if I do a cout statement, that's going to show the positive. Let's show you. I think I have the example right here. Okay, here's our example. Maximize that a little bit so you can see it. When it does this cout statement, it's going to show a positive and it's going to show the decimal point. Now if I do a cout.unsetf, that just says don't show the positive anymore and don't show the decimal point anymore. So it shows just as a normal number. So these are ways of affecting the stream. Now this cout could be replaced for the file and it would do the same thing for your file. Okay, so this is how we would do show point. You also have alpha, show base, skip white space. There's a couple others you have in there. One that's kind of nice is this fixed iOS flag, and I believe we've actually talked about these flags at the very beginning of the year. This is just kind of review in case you need it. So here in this example, and it's I've got another code on Replit. Let's use that. Okay, here we go. So I've got a decimal point and it's to a gazillion different decimal places, and then I show what the default is. I show what A and show what B is. Now I specify to set precision to 3. So at this point when I say set precision to 3, it's specifying, this is the original, this is the overloader. So here's where our set precision is 3, and it just shows 3 decimal points. It doesn't actually show it doesn't show 3 decimal points, it just shows 3 numbers. And you'll notice it put our huge number into exponential notation because it was already larger than 3 decimal places. Now if I specify fixed, std fixed, then it fixes it so that it always shows at 3 decimal points. Okay, so now these iOS flags are not affecting the actual data itself. It's only changing the stream to display that information. So you still have your digits of precision inside the variable. Here's another little example we could show you. This one is on set width, and so this is specifying to set the, let's show you this one as well since we can. So it's setting the width to 6 and lining these up just straight, and then it's showing you the oct, the hexadecimal, and the decimal versions of each of those numbers. So it's showing decimal, it's showing oct, it's not showing oct. I don't know why it's not showing oct. Oct should end at, oh yeah, it is. It gets to 8 and then prints 10, 11, 12. So oct is base 8, sorry. Then it shows the hex version. Okay, now here's what we're really looking into. We're going to start using for file input and output, this fstream library. And in there, there's ifstream, ufstream, and filestream. The file types you can possibly write to are unlimited, but there's two basic types. You could do some sort of text file, and that will open with a text editor. For example, there's a txt. We're going to use a JSV file, which is just a comma delimited file. .java, .cpp, those are all text files. Binary files are things that you would open with specialized programs, such as an exe, was kind of it's a binary file. A PNG, you use some other program to open that file. Same thing with an MP3. Although it doesn't seem like it, a zip file is actually a binary file. It's compressed. Now there's two different ways to access data in the file. Now, the one way is to use a sequential access file, and what that means is the data and the information is just put in order, and in order to access the end of the file you have to go through and access all the data before it, versus a random access file where you can jump around. Now the easier one to code is a sequential access file, so that's kind of what we'll deal with today, but you can do different ways of storing your data to get a random access file. Let's give you an example of both. Here's an example of a random access file. If you wanted to remove ball 3 from this box of tennis balls, how would you do it? Well, yeah, you just reach in and grab ball 3, and that would be pretty easy. That's an example of a random access file. Now I'm going to compare that to a sequential access file. If I wanted to remove ball 3 from this tennis can, could I just reach in and grab ball 3 and pull it out? No. You have to go through and you have to take out ball 1, you have to take out ball 2, and you have to take out ball 3, and then you have it. So keep that in mind when you're accessing this data. Whenever you read information from your file, you have to start at the beginning of the file and read down to whatever data it is you want to access. So here's an example. I've got a text file called shoppinglist.txt. I want to access donut. How would I do that? Well, first I have to read in the first value. I have to read the next value, have to read the next value, and now I can access the one I'm looking for. Okay, here is an example of how you would read information from the file. So in this case, I'm using ofstream. And the reason I'm using ofstream is because I'm writing out to a file. If you're writing out or if you're appending either one, you'll use ofstream. So I declare the variable, so out is of type ofstream. And then next I'm going to open the file, and I use that with the open command. This is the name of the file that you're opening. If you are going to store this file in the same location as your .cpp file or wherever your .exe gets created, then you don't have to put a path. You only have to put the path in like the c:// if it's someplace else. So this is the name of the file that's getting opened. This is the direction, where it's opening, how it's opening. So in this case, it's going to write out to the file, and it will overwrite everything that's already there. So if you open the file with iOS out, everything in the file is going to get deleted, and then it will write out the new information. In this case, it's just writing out the text, hello world. In this case, it's just like a cout statement. Instead of cout, I put out, or whatever I happen to name my ofstream. Then whenever you open the file, make sure to close it. Don't leave any barn doors open. If you want to see an example of what this code looks like, oops, I don't have that, do I? I went back the wrong way. Give you an example. We'll kind of change this code around so we can see what this looks like. So instead of hello world, we'll do, I don't know, hello crazy world. There we go. So right now it's going to open the file. This file doesn't exist, so it's going to create, if you notice I have no files here, if I run this file, it's going to create this text file, and it's going to write this text. If I'm going to click on this file so I can see it, there it is. And that information stays there so long as I don't run this program again. But this is now data that's saved. Oh, now I have all the animations. Oh yeah, here's what we changed. All I have to do is change this iOS flag. I'm going to add this iOS : app, and that will append to the file instead of overwriting it. So let's look at that too. Let's escape out of this one, come back to this one. Okay, so if I change this text, instead of crazy world, I'm going to say hello, let's say goodbye. Run this, creates my file called hello, but if I look in, my hello crazy world is gone and it just says goodbye crazy world. Now if I go back, instead of iOS out, I'm going to say iOS : app, that's append. Okay, now let's change our text again. Let's do like hello again. So if I run this now, take a look at my file, and it has both of them, and I can run this several times and it will just keep appending onto the file. Okay, so it didn't that time, but you know, there it goes. So it just keeps adding to the end of the file, by the way. Alright, so those are my flags. Out means just write out to the file and erase everything that's there. Append means just tag everything on to the end. Oh, what's the difference? So in this particular command, I have 2 lines of code to declare the object and to open the file. There is a simplified way. You can declare it and open it at the same time. You still do have to close the file. So both ways work. This is just kind of a simplified way. You're declaring and opening the file at the same time. Okay, reading from a file. A couple more functions, a couple trickier things on reading from the file. So in this case, instead of OF stream, I now have IF stream, input file stream. And I usually call mine, I don't usually call it in, I usually call it fin, because that way it looks like a CIN statement, but instead of going to the console, it's going to the file. And so that's kind of what just a standard naming practice I have for it. You'll see that often. And the only difference is you still have your text file. You do not have to have a path if numbers.txt is in the same location as your exe file. And then instead of iOS out or iOS append, you have iOS in. Couple things, there's a couple methods you can use with this fin. You could say EOF, end of file. So you could put that sort of like in a while loop, keep reading so long as it's not the end of the file. And there's also good, fin.good, meaning is the stream error free. Okay, here is an example, and what this does is it has a text file called numbers, and there's a bunch of numbers loaded into it. And then it has this while loop. It opens up the file for reading, and so long as it's not the end of the file, it reads in the numbers. So long as it's good, it continues to display the information in the output. Let's take a look at this example. Maybe if it loads. Okay, so here's my numbers. I've got 1, 3, 4, 6, 7, 9, 3, 5. If I run this program, there is no numbers there. It's just reading everything from the file. I hit run, and it's going to go through and it's going to say 1 plus 3 is 4, 4 plus 6 is 10, 7 plus 9 is 16, 3 plus 5 is 8. And here's where it's doing that. It shows the first number, it shows a plus some number, the second number equals, and then it adds them together. Alright, so that is the end of our input file stream. Join us for the activity in the lab in the next class, and we will see you there.